Welcome to this tutorial on how to set up a lesson regarding airspace. For starters, I'm going to start out using skyvector.com. Skyvector.com is a great resource that has basically one large sectional chart for the whole country. Now you can purchase regular sectional charts, paper maps. They're very large for different sections of the country. This is a very convenient tool, especially if you have continuous internet, let's say on a larger iPad where you're at, and so very handy. Now I've got the Sioux Falls Regional Airport, and here I've got this blue dot, or blue dotted line I should say. We've got Class D airspace with a floor of the surface that goes all the way up to 3,900 feet. Then we also have our Class E airspace that outlines this, and we've got a ceiling. Let's see, where's my ceiling of that? Ceiling should be 18,000 feet, and it starts at 700 feet above ground level. So how do we know what that means, though? How do we visualize that? And so one thing that I want to show you is how to take a look at that using the Google 3D Warehouse. Now I'm jumping to another. Now I'm jumping to another map here. This is San Francisco International Airport. Now this looks like a hot mess if you're looking at this. There's a lot going on. This is mostly all Class B airspace with a lot of surrounding Class C airspace with this solid magenta line here. You know it's Class B because we got a solid blue line here. Now someone has taken the liberty of going into the 3D warehouse, and they created a work in progress. And so if I'm going to zoom in on this, let's zoom out of this. This is kind of an overview. I don't know if this is the exact same airport. This says San Mateo, I believe, so it's close enough to where you get the general idea. Is here I've got all these concentric circles, and if I'm looking over the top of this, it looks like a hot mess. Now, if I use my tools in 3D Warehouse, I'm going to use this orbit tool, and I'm going to pan to the side. This will make a lot more sense in a little bit. This looks like an upside down wedding cake, and that's exactly what this is supposed to look like. And as you have surrounding other airports outside of these other airports, they have their own airspaces as well, in addition to Class E airspace. And then here's some Class C airspace that you see along here. And then you got like international boundary waters and whatnot. So, or you've got boundary waters in here. We won't get into that because probably, quite frankly, won't ever get into that whatsoever. Here you see the shaded line. This is Class E airspace that starts at 700 feet above ground level. Now let's take a look at this. This person was very gracious enough, whoever made this, to note that here, let's go to the middle, let's go to pan here. As I go in here, this goes from surface to 10,000 feet, and you're like, well, there's 100 here. You add 2 zeros on this at any time, so 100, 00 is 10,000 feet. So from the surface to 10,000 feet is where this concentric ring lies. So that's that airspace. And then above that, from 10,001 up to 18,000 feet, you're looking at Class G airspace. And then at 18,000 feet to 60,000 feet, you're looking at Class A airspace. So here we go in, and as we look at these other concentric circles, we've got, let's see, that's not a good one. This one's from 10,000 feet to a floor of 5,000 feet. And then this one's got to 4,000 feet. This one also is 4,000 feet. Now note that the further you go out, typically it gets higher. I don't know what this is, but that doesn't look correct. This looks correct. This is from 10,000 feet, this outer concentric ring, to 8,000 feet. And so remember, we add those 2 zeros, and that gives us a floor of 10,000 or of 8,000 feet. So that's where this lies right here. Now, if I'm looking at this, this is Class C airspace, this red ring over here on this airport. So if I'm looking in this center concentric ring, I've got from the surface to 4,000 feet, and then on the outlying side, if I can maneuver that around a better. Yeah, from 4,000 feet to 2,500 feet. So basically, so the top is 4,000 feet. This is 2,500 feet. That's where that outer ring lies. And so typically you'll see like 5 nautical miles out, 10 nautical miles out is where you'll see these rings continually get out. So not always. Sometimes they have the really weird, goofy sections on there. Let's take a look at another airport. Let's hit escape. And I love 3D Warehouse. It has anything and everything if you've never used it. Here we've got some different runways. Sometimes when you see airports in SkyVector, let's go back to Sioux Falls. All right, we're back to Sioux Falls here. So as we're looking at Sioux Falls Regional Airport, once again we've got a Class D airspace with this dotted blue line, and it goes from the surface to 3,900 feet up. On the outlying area, don't worry about this. This is more of a compass. This tells you where your true north is, and so there's true north. It's going up. And we've got here our Class E airspace with this gradiated magenta line. And for this area, it goes from 700 feet to 18,000 feet. So as we go into this, if I zoom in on the airport, it tells me where my airstrips are going. And if I click on this specifically, I should say my landing strips, the landing strips should go, let's see, where's the first one at? So my runway 3 is at 30 degrees. Runway 21 runs at 210 degrees. So I'll remember for these we just add 10 to this. So at 30 degrees and then at 210 degrees. Those are determined by the headwinds, or the where your headwind runs. And so when the headwinds either fly a certain way or run a certain way to where you want to fly into the headwind to take off. You want the maximum amount of speed over the wings to get lift. So that's why in this area, this is why these runways are the way they are. So with that, let's go into an airport section. As you study airports, you'll learn that there's certain traffic patterns to each airport. And then with traffic patterns on here, there's reasons why there's downwind and then there's upwind. And you'll find out that sometimes when the wind changes, it might be more advantageous to land on a different runway. So, and each landing strip's got a certain amount of feet to it, and that the towers tend to be in different locations on the runway. Some airports have no towers, so, and you'll find out in some of these. Where's another airport? Here we go. Here we've got one where the tower sits right in front of this runway. So very simple airport. This actually has, I believe, an underground parking area as you back up from here. Maybe not. There's one, oh yeah, right here. So here's an entrance tunnel into this, so you can get right to the ATC, Air Traffic Control Tower. And this one has one runway. So let's move on. Let's take a look at, now these are all, this is Class B. These should be all Class D, I believe. Yeah, all these outlying ones are all Class D airspace. So here as we're looking at this, we move up above. You can see that, very simply put, here's where this airspace lies. And so very easy to, oh, I'm sorry, this is a Class E airspace. And the way I can tell is that it just floats. It's like a floating pancake up above here. So my apologies, not Class D airspace. This is Class E, and you can tell because it starts at 700 feet above ground level. So from here to here is all open space. Typically you would be able to fly in there, although not necessarily a wise decision because there is a lot of traffic going in here. So if you're flying a drone, you would want to get air traffic control or at least FAA permission to go from surface to E. That way they know you're in the area. And typically the closer you are to an airport, you would request that you would not fly in this area. It's just good practice not to. So do something smart, safe around this area. If you do need to fly close, and this is a non-towered airport, then you would want to make sure that when you do an airspace authorization to the FAA, that you would ask that you would go no more than so many feet. Like I don't plan on getting more than 50 feet than this. So hopefully that hasn't fried your brain totally, but I'll stop there for now. And if you have any further questions, let me know.